Okay, let's unpack this. If you are serving on a modern naval vessel, you are navigating what is perhaps the single most complex, integrated environment humanity has ever designed.
Oh, absolutely.
We're talking about massive radars, complex sonar arrays, networked missile systems, and data processing centers, all running simultaneously.
All linked by hundreds of miles of cabling, all designed to fight, survive, and, well, win.
It is absolute technical complexity housed inside a steel shell, and the integration required is just staggering.
It really is. Now, imagine all of that chaos when something critical fails, a catastrophic casualty event.
Right.
The clock is ticking, the mission is at stake, and safety is on the line. How do you manage the technical recovery, the system reconfiguration, and the overall readiness of those high-stakes combat systems without spiraling into absolute unrecoverable confusion?
The answer can't be improvisation. It just can't. The answer has to be a formalized, mandatory system that dictates who responds, where they go, and how they execute the recovery.
And that structured answer, down to the second, is the focus of our deep dive today.
It's the Combat System Operational Sequencing System, or CSOSS.
Exactly. For any of you tasked with understanding naval readiness policy, or maybe preparing for a high-stakes technical examination, or even drafting a comprehensive administrative memo, this deep dive is pretty much essential.
We're really focusing on the foundational knowledge here.
We are. The definitions, the strict organizational structure, the mandated requirements, and especially those critical numerical timelines that define how fast the system and the technical authority must react.
And our source for this is the Bedrock policy itself.
That's right. We're focusing specifically on the 2012 Naval Surface Force Instruction, Force of 7 90.9.
Our mission today is to take this, let's be honest, very dense administrative instruction and translate it into clear, memorable, and actionable knowledge.
We want you to walk away understanding not just what CSOS says, but why it is the mandatory standard for technical safety and mission effectiveness.
And this instruction, the Common Navi Surf Pace and Est 4790.9, it establishes CSOSS as the mandatory, what's the phrase they use?
The procedural baseline, that's the key term. It's the baseline for all combat system equipment operations and, critically, for casualty control.
And to really grasp the significance of this, we need to look briefly at where this structure even came from.
Yeah, that's a great point.
Because CSOSS isn't a new concept, it's a refinement, right? It's based on decades of lessons learned regarding how to safely operate complex machines under stress.
Precisely. The intellectual lineage, if you will, goes back much further than the modern age's combat systems. It draws directly from the highly successful Engineering Operational Sequencing System, or EOS, which was established all the way back in 1976. EOS was created to standardize the procedures for the ship's propulsion, power generation, and auxiliary systems.
So before EOS, engineers might have just followed local, undocumented procedures.
That's the thing. It could lead to unnecessary risk during critical evolutions.
So the black jacket world, the engineering world, got standardized first, which makes sense given the extreme danger inherent in operating steam plants and complex, high-pressure systems.
Exactly. And by the late 1980s, there was a recognition that combat systems had grown equally complex and just as vulnerable to human error during casualty control.
So CSOSS was formally established in 1987.
Correct. The instruction we are reviewing today formally directs its use on specific modern ships, and it directs its application for all conditions of readiness.
From relaxed peacetime cruising all the way to conditioned general quarters.
Every single one. So this is a policy mandate. CSOSS acts as a readiness management tool, and it complements the maintenance schedule defined by the Planned Maintenance System, or PMS.
That's a really important distinction. It's not about fixing broken parts. It's about standardizing the technical operation and the recovery of the combat system, 200-47.
That distinction is key. You've nailed it.
All right, let's start with the absolute essentials. If you are asked to define CSOSS, what are the 2 or 3 most critical phrases that encapsulate its entire purpose?
The core definition, which must be drilled down, is that CSOSS is the procedural baseline.
There's that phrase again.
It's the one to remember. The procedural baseline for combat system operations and casualty control. That phrase means it is the required, vetted, standardized method of operation. You can't just deviate without cause, and we'll definitely get into that accountability later.
And the objective, I mean, why bother with this massive organizational effort?
The primary objective, the overarching goal of this entire massive administrative structure is really simple: to maintain the highest possible levels of combat system readiness.
Okay.
And it achieves this by providing technical procedures, The instruction is very deliberate about what it provides and what it does not.
That's a crucial point of differentiation, I think. It's one that often confuses people new to naval operations. CSOSS provides technical procedures, not tactical material.
Correct. CSOSS doesn't tell the combat systems readiness officer or the tactical action officer where to position the ship or which target to prioritize. It tells the technical staff, the technicians on the deck plates, how to safely bring up the radar, how to switch a system from primary power to alternate power, or how to reconfigure a missile launcher after a fault.
So it's the mandatory engine instruction set for the weapons and sensors.
That's a perfect way to put it. It focuses on the technical how, ensuring the tactical commander always knows the status and the capability of their weapons.
Okay, if the goal is readiness and the tool is standardization, what is the philosophical foundation this whole system rests on? If you strip away all the paperwork, what's the simple concept that stops the chaos?
It's known as the three pillars, or you'll hear it called the three Ps, and it defines the essential relationship required for successful CSOSS operation and readiness management.
And if any one pillar fails, the system fails.
Exactly.
Let's list them out clearly.
Okay, first, people. This requires trained, qualified personnel at assigned watch stations. Training is not optional. Formal qualification is absolutely mandatory.
Pillar 1, people. Got it.
Second, procedures. These are the step-by-step readiness actions. The CSOSS documentation itself, which we'll discuss in more detail later.
And the third?
Third is places. These are the key organizational areas, the watch stations, like the CSMC or various equipment spaces, distributed throughout the ship.
So this is where the trained people execute those standardized procedures.
Exactly.
That sounds elegantly simple.
Huh?
The right trained person in the right place with the right procedure. But let's delve into the implication there. If, for instance, you have the procedures and the places, but the person operating the gear is unqualified, what is the immediate risk?
Well, the risk is catastrophic equipment damage, or even worse, personnel injury.
Right.
Because CSOS involves sequencing high-voltage power, complex cooling systems, and dangerous transmitters. An unqualified person following the steps but maybe missing some critical context or skipping a step due to a lack of training can turn an operational evolution into a casualty event very, very quickly.
So that emphasis on trained personnel is really a safety barrier.
A critical one. It means CSOSS doesn't just manage the equipment, it manages the human interface with that high-risk equipment.
And that human interface is rarely isolated.
No, never. And that leads us to the final foundational requirement, integration. CSOSS procedures are not designed to function in a vacuum. They must be seamlessly integrated with the Engineering Operational Sequencing System, EOSS, and the appropriate damage control bills.
Why is this integration mandatory? Why can't the combat system department just operate entirely separately from engineering?
Because combat systems are entirely dependent on auxiliary support services. They need specific levels of electrical power, often high-pressure air for systems like launchers, and constant, reliable chilled water to cool, powerful radars and computers.
And all of that comes from engineering.
All of those support services are controlled by engineering, which means they use EOSS procedures. So if the chilled water pump fails, that's an EOSS casualty, the combat system team using CSOSS must know immediately how to mitigate the effect.
Like maybe by shutting down the highest heat-generating components to save the mission-critical sensors?
Precisely. A CSOSS recovery procedure often starts with or includes a coordinated step with the engineering officer of the watch.
And similarly, damage control is unavoidable.
Absolutely. If there is a fire or flooding in a weapons space, a damage control bill situation, the CSOSS organization must coordinate with the DC team to ensure that systems are electrically secured for safety before DC efforts begin.
And to make sure access routes are clear for the DC teams.
That's right. Readiness is truly a joint, integrated evolution.
So to recap this first part for anyone taking notes, CSOSS is the mandatory technical procedural baseline for readiness.
Right.
It's built on that mandatory relationship between people, places, and procedures. And crucially, it is integrated with EOS and damage control because no complex system operates in isolation.
That's a perfect summary.
Okay, moving from to the who controls and mandates it. When we talk about standardization across an entire fleet of ships, from destroyers to carriers, who holds the ultimate technical authority for CSOSS?
Standardization requires a single, accountable entity. The technical authority for CSOSS development, its validation, implementation, and its entire lifecycle maintenance rests with the Naval Surface Warfare Center Port Huon Division.
also known as NSWC PhD.
That's the one. They are essentially the institutional brain that writes the book and validates its contents.
The master librarians and the architects of the procedural system.
Yes, specifically assigned by the commander, Naval Sea Systems Command. This centralization ensures that a procedure written for one DDG-51 class destroyer is applicable, with only localized tailoring to all other DDG-51s of that flight.
And if the fleet submits feedback requesting a change, NSWC PhD is the only authority that can approve, vet, and disseminate that change.
That's it. That centralization also ensures consistency in the training requirements, which are, well, non-negotiable for the personnel using these procedures.
Absolutely. The policy is rigid on this. All CSOSS operations, from a basic startup sequence to a complex casualty reconfiguration, must be conducted by personnel qualified in accordance with specified naval references, primarily Navy Saints 4790.7.
And that qualification requirement links directly back to that people pillar we talked about.
You have to be certified to execute these technical steps because of the risks involved. It's a measure of high accountability.
It is.
So if a ship has formally implemented CSOSS, what does the instruction mandate regarding its use? Is there any gray area where a commanding officer could say, we prefer our local checklist for this?
There is no gray area. Ships formally implemented must incorporate CSOSUs to ensure the optimum readiness of the combat system.
A mandatory requirement.
It's the governing technical manual. Furthermore, the ship must establish local doctrine that governs the CSOS organization for all watch stations under all conditions of readiness.
So whether you are in port or at sea, whether you are at Condition V or Condition I, the CSOSS structure defines the command and control pathway for technical readiness.
That's right. So the standardized organizational charts we see for ships like the CG-47 or DDG-51 are just the starting point. The ship has to tailor that baseline, but the structure and the roles defined by CSOSS are mandatory.
So you might have a modified baseline for your specific configuration, but the fundamental roles, CSOOW, CSRO, AS, and their responsibilities must align with the instruction.
Precisely. It prevents individual command philosophies from compromising fleet-wide technical safety standards.
Let's turn now to the essential training mandate, which ties accountability across the different technical spheres we mentioned earlier.
Okay. The instruction mandates that ships must plan, coordinate, and execute casualty control training that involves both CSCAT combat systems and EOSS engineering. This cannot be done separately.
And this is the domain of the integrated training team, the ITT.
Correct.
So the ITT isn't just teaching people how to flip switches, they are teaching them how to communicate under stress when two different technical domains collide.
That's the key insight. When a ship performs an integrated drill, say a major power distribution casualty that impacts the radar.
An EOSS failure causing a CSOSS problem.
Exactly. The ITT ensures the engineering team knows when to isolate, and the combat system team knows how to restore the minimum required capability, all while the damage control team is prepared for any secondary effects.
So this integrated training ensures seamless cross-departmental readiness.
It does.
Okay, let's recap this part. NSWC PhD owns the entire technical life cycle of CSOSS.
Right.
Implementation is mandatory for optimum readiness using qualified personnel across all conditions.
All of them.
And the ITT ensures casualty training integrates combat systems procedures, so CSOSS, with engineering procedures, EOSS.
That nails it.
Now we transition from the administrative requirements to the operational structure, the critical people and places. If a major casualty occurs, understanding this hierarchy is the difference between a controlled recovery and a total system collapse.
This organizational structure is literally the script for handling the chaos. And as you noted, baseline charts exist for various ship classes, CG-47 Aegis cruisers, DDG-51 Aegis destroyers, LHDs, carriers. But the functions are universal, even if the physical locations might vary a little.
So let's focus on the flow during Condition I, which represents the highest state of readiness, the mission-based watch organization. Where does the technical authority plug into the tactical fight?
The flow begins in the Command and Control Hub, the Combat Information Center, or CIC.
Right.
The commanding officer or the tactical action officer conveys tactical priorities. These priorities are then translated into technical action items for the Combat Systems Officer of the Watch, CSOOW.
But there's a translation layer in between.
Yes. The Combat Systems Readiness Officer, or CSRO.
The CSRO is that crucial bridge connecting the tactical, what we need to do, with the technical, how we can do it.
Exactly. And the organizational charts show this flow using different lines, which are incredibly informative about the system's priorities. We should probably break down that visual language.
Yeah, let's do that. What do the solid lines represent?
Solid lines indicate the primary communication and coordination paths. This is the normal, active flow of command, who reports directly to whom. It represents the immediate, direct link for direction and status updates during standard operations.
Okay, and the dash lines. This often confuses new students.
Dashed lines indicate restoration paths. These are used when the system is broken or undergoing maintenance.
Ah.
This line is the direction used when the CSOOW needs to contact technicians who have been dispatched to maintenance bases, or when they coordinate logistics, like contacting supply for parts. It signifies the maintenance or casualty correction action required to restore readiness.
So if the CSRO is talking to the CSOW about the fight, that's a solid line. If the CSOW is telling a technician to replace a power supply, that's a dashed line.
Perfect distinction. The solid line is operational command. The dashed line is maintenance command.
And what about the third type, the dotted lines?
Finally, the dotted lines represent tactical nets. The instruction specifies that these networks are reintegrated into the tactical organization after restoration is complete.
That implies a cycle then. When something breaks, the technical team uses the dashed line to fix it.
Right.
And when it's fixed, the tactical net, the dotted line, lights back up to say, we are back in the fight.
That's an excellent way to conceptualize the structural flow. It shows the whole process visually.
Let's start at the top of that hierarchy, with the role that translates the fight. The Combat Systems Readiness Officer, CSRO. Where are they located, and what is their constant pressure?
The CSRO is located right in the thick of it in the Combat Information Center, CIC, and they are manned specifically during Condition I.
Maximum readiness.
Exactly. Their pressure is integrating the immediate tactical situation with the long-term technical health of the combat system.
What are their primary duties beyond just being a conduit for communication?
Their functions are strictly advisory and control. They advise the CO or the TAO on the immediate impact of any system casualties. And more importantly, they report the remaining capabilities.
And the expected status of repairs?
Crucially, when systems go down, the command needs to know what weapons and sensors they still have available. That crucial assessment comes from the CSRO.
That's a high-stakes advisory role. If they misreport remaining capability, they could seriously compromise the mission.
Absolutely. They are also responsible for translating the CO's tactical requirements, like, we need that anti-air radar back online within 5 minutes, into concrete restoration priorities for the CSOOW.
And they maintain overall control of the CSOS organization during critical shifts or transition.
They do.
Now, let's look at a closely related role, one often found on our most advanced vessels, the Combat Systems Coordinator, CSC.
The CSC is a specific, very demanding watch station primarily found on Aegis-class ships, so your CG-47s and DDG-51s.
Where are they located?
They can be either in the CIC or the CSMC. And like the CSRO, they are manned during Condition I. Their primary duty is hands-on operational.
Okay.
They operate the CSC console, they perform necessary tactical operations, and they maintain a continuous technical monitor of equipment performance. They are the high-level system monitor.
And what makes this role particularly demanding in terms of qualification?
This is a big one. The instruction requires the CSC to be a qualified CSOOW in addition to being a qualified CSC console operator.
So they have a deep understanding of not only the operational nuances of the console, but also the procedural backbone, CSOSS, needed for readiness management and casualty response.
Exactly. They are the technical expert who can immediately translate a system fault message on their screen into a defined CSOSS action plan.
That combination of immediate operational control and profound technical knowledge, that really sets a high standard for console manning.
That's a huge responsibility.
So let's synthesize those two CIC-based roles before we move to the control center. The CSRO, located in CIC, manned in Console I, is the strategic bridge.
Right. Advising command and setting restoration priorities based on the tactical fight.
And the CSC, on Aegis ships, is the highly qualified console operator, combining tactical execution with readiness monitoring.
Perfect.
We move now to the operational hub, the nerve center of all technical operations, the Combat Systems Officer of the Watch, CSOOW. If the CSRO is the translator, the CSOOW is the conductor.
The CSOW is the single essential figure for procedural compliance. Their location is the Combat System Maintenance Central, CSMC.
And their manning status is critical for policy understanding.
It is. They are manned in all conditions underway, all of them. And they are required to be on call after working hours in port.
So if the ship is moving, the CSOW is available.
Always, making them the constant central authority for technical readiness.
Why is the CSOOW role designated as the central control watch station?
Because their primary duty is coordinating all CSOSS-based operations. They maintain positive control of combat system safety and security. They direct system initialization, configuration changes, and all casualty control efforts according to the published procedures. They are the procedural gatekeepers.
Let's visualize the CSMC for a minute. It's not just an office. It's a pressurized environment where the operational status of the entire combat system is tracked.
Absolutely. The CSMC has to be a centralized area designated by the CSOW, and it's outfitted with mandatory equipment.
Right.
Comprehensive status boards, a full set of CSOSS reference materials, your CSOP, CSOCC, support data and reliable internal communication equipment. Imagine a room dominated by status panels, showing which systems are powered, which are configured, and which are tagged out for maintenance. The CSOW lives in this constant state of configuration management.
And their administrative functions are just as vital as their operational ones.
Oh, yes. They track all configuration changes, ensuring they always know the exact state of every component. They maintain the official combat system's tag-out log, a critical safety function, and they coordinate inter-system planned maintenance, or PMS activities, ensuring that scheduled maintenance on one system doesn't accidentally interfere with another.
Now let's focus intensely on the CSOW's coordination role, because this is where that policy on integration becomes operational reality. They are the liaison between technical departments.
That's right. They coordinate support services through the Engineering Officer of the Watch, EOOW. For example, if a high-power radar needs to be brought online, the CSOW coordinates with the EOOW to ensure sufficient power, chilled water, and cooling system lineups are established before the procedure even begins.
So they are constantly managing the technical relationship between the ship, or EOS, and the weapons, CSOSS.
Constantly. And their coordination with damage control is just as important.
And what about that?
They coordinate with the Damage Control Assistant DCA for two major reasons. First, damage reporting, confirming what combat systems are impacted by flooding or fire.
And second,
Coordinating DC access routes and assistance during casualty situations. If a technician needs to get to a flooded space to secure power, the CSOW coordinates that technical work with the DCA's safety protocols.
So the CSOW is the operational hub, linking combat readiness with engineering support and damage safety.
That's their world.
Given the absolute criticality of the CSMC, what redundancy does the instruction require?
Because the CSOW is the continuous central authority, the instruction mandates that a secondary CSMC and alternate combat system maintenance central must be designated.
And this secondary location has to be in another part of the ship.
It does. And it has to be fully outfitted with status boards, comms, and procedures to support all CSOW functions in case the primary location is damaged or requires abandonment.
That policy reflects the high stakes of maintaining control even during a casualty. That concept of mandatory physical redundancy just underscores the non-negotiable nature of the CSOS structure.
It really does.
So to synthesize this part, the CSOW and the CSMC, manned whenever the ship is underway, is the operational hub.
Yes, responsible for technical control, safety, security.
And linking combat readiness with both the EOOW for engineering support and the DCA for damage control.
Right, and the CSMC must have a mandatory backup, the secondary CSMC.
Got it.
Now we drill down to the action level.
The personnel executing the procedures on the deck plates, who manages the people carrying out the CSOSS procedures in the equipment spaces?
That responsibility falls to the Action Area Supervisor, or ARAS.
Okay.
The ARAS maintains direct supervision over a specific area of the combat system, like the missile deck, for instance, or a specific radar transmitter room. They are manned during Condition O, and crucially, their manning in Condition 3, which is a lower state of readiness, is conditional.
What dictates whether an ARAS is manned in Condition 3?
It depends entirely on the ship's mission, its operational tempo, and the required casualty response time that the CO or TAO has deemed necessary.
So if the ship is in a low-threat environment, they might be on call.
Correct. But if the mission dictates a recovery time of minutes, not hours, the AAS watch station must be manned to expedite response and coordination with the CSOOW.
And what are the AAS's core duties in their assigned area?
They are the local managers. They track configuration changes locally, they maintain local status boards, and they coordinate the efforts of the action area personnel under the CSOW direction.
And they hold significant safety responsibilities as well.
Huge ones, including executing emission control, EMCON and radiation hazard, RADHAZ, control within their area. They're ensuring personnel safety and operational security. And they're also responsible for the execution of the emergency destruction bill within their designated space.
Finally, the people who make the system work, the action area personnel, who come in the form of operators and technicians. Let's focus on the technicians, as they are the ones who embody the technical proficiency mandated by CSOS.
Technicians are the ground-level experts. They are essential for initialization, configuration, and casualty control. They perform virtually all system readiness actions and are the primary source of real-time equipment status for the ADS.
And they're the ones informing the chain of command of readiness conditions and the estimated time to repair.
Yes, and this is the critical detail for anyone focusing on policy or safety accountability. The specific authority granted to technicians.
What is that?
The source material is unequivocal. This is a vital safety and legal demarcation. Qualified technicians are the only Purley personnel authorized to perform equipment repair under the direction of the AAS or CSOW.
So while other personnel like operations specialists might assist in monitoring or operating the physical act of repair.
The turning of wrenches, replacement of components, or complex reconfiguration is strictly reserved for those holding the formal qualification.
This policy mitigates risk by ensuring only proven experts touch the high-risk equipment.
That's its entire purpose.
And the operators and operational supervisors. Operators provide the initial, timely symptom information by reporting any abnormal equipment performance. They are the eyes and the ears. And the supervisors. Operational supervisors, which might be a CIC watch supervisor, for example, oversee the operators and technicians. They provide vital decision-making for maintaining tactical capability during casualty situations, ensuring that the technical recovery effort aligns with the overall combat mission.
So let's sum up the action level. AKS supervise the immediate areas, managing local configuration and critical safety procedures like MNCON and RADI-HAZ.
Yes.
Technicians are the indispensable qualified repair experts and, critically, the only ones authorized to perform repair actions.
The only ones.
And operational supervisors integrate that technical recovery back into the tactical plan.
That's the whole chain? Okay, we've established the structure, the who, and the locations, the where. Now let's move to the procedures themselves, the physical documentation that drives this whole administrative system.
And this structure is key to separating routine operations from emergency response.
How so?
The CSOS documentation is packaged into tailored books and placed strategically throughout the ship, accessible right at the watch stations and equipment spaces. This package is made up of 3 essential, interdependent subsystems.
Let's look at the first two, which delineate between normal operations and casualty response.
Okay, number 1 is Combat System Operational Preparation, or CSOP. This section houses all procedures covering technical, non-casualty processes.
So things like standard alignment sequences, preparation for starting up operations.
Sustaining operations over long periods and planned configuration changes required during normal status. If you are conducting a scheduled power alignment or a sensor calibration, you are using CSOP.
And when things go wrong.
Number 2, that's where the Combat System Operational Casualty Control, or CSOCC, comes in. This is the emergency playbook. It provides detailed casualty control and emergency procedures, including necessary system reconfiguration steps required to mitigate the effects of a casualty or to overcome a fault. If a pump fails, the CSOCC procedure dictates the specific response, including which secondary pump to bring online and which primary system needs to be secured immediately.
So CSOP is planning and sustainment. CSOCC is reaction and recovery. What about the third component?
The third component is support data. This is the essential reference library that provides context for the procedures. It includes system diagrams.
Showing power distribution, airflow, that sort of thing.
Exactly. And data tables, status boards, interface diagrams, and handbooks that provide contextual information necessary to understand why the procedure is written the way it is.
That clear delineation, CSOP for routine, CSOCC for emergency, is the reason the system can react so quickly. The watch standard doesn't waste time figuring out if a failure is normal. They simply grab the appropriate book based on the situation.
That's the idea.
We discussed the ITT's role in integration, but who ensures the proficiency of the individual sailor and the teams on a day-to-day basis?
Well, initial foundational CSOS training is provided by the afloat training groups, or ATG, during implementation. They set the initial standard. But the internal, continuous responsibility for readiness assessment falls to the ship's own training cadre.
The Combat System Training Team, or CSTT.
Correct.
What exactly is the CSTT's operational function regarding CSOS?
The CSTT regularly exercises the CSOS organization through drills, specifically combat system evolutions and casualty control drills.
They work with the ETT and DCTTs on integrated drills, like the crucial casualty control exercise.
They do. But most importantly, the CSTT is responsible for assessing watch station proficiency across the entire CSOS organization. They are the internal auditors, ensuring that People Pillar remains rigorously tested and competent.
This proficiency assessment is nonstop because the equipment is nonstop, but the equipment itself is constantly evolving. How is the life cycle of the documentation managed when hardware and software are always changing?
CSOSS requires periodic continuous modernization. It's a formal process called lifecycle maintenance, or LCM.
Because systems are upgraded, removed, or replaced?
Right. Think software updates or new sensor installations. The procedures have to keep pace. NSWC PhD, specifically code A34, manages this LCM, and updates are triggered by two very specific recognized events.
What are those triggers?
First, scheduled updates. These are usually tied to major ship availabilities or scheduled updates mandated by the Chief of Naval Operations. These are planned cyclical revisions.
And the second one?
Second, and much more dynamically, updates are triggered by the submission of a technical feedback report, or TFBR, from the fleet.
The TFBR. That's the official channel for the sailor on the deck plates to communicate flaws or required changes back to the system's architect, NSWC PhD.
It is the essential feedback loop that prevents procedures from becoming dangerously obsolete.
Let's synthesize this section then. The CSOSS documentation is split into CSOP for routine preparation and CSOCC for emergency casualty control.
Yes.
The CSTT rigorously assesses watch station proficiency, and the documentation is updated by NSWC PhD, triggered either by a scheduled availability or by a fleet-submitted technical feedback report, TFBR.
That captures it perfectly.
We've reached the final, most numerically intense section. For anyone focused on policy and administrative accountability, the TFBR process defines the relationship between the fleet and the technical authority through rigid, mandatory timelines.
This is where we see the high stakes quantified into strict deadlines. TFBRs are the standardized mechanism used to generate CSOSS updates, corrections, and recommendations during a ship's operating period.
They are submitted to report procedural errors, technical discrepancies, recommendations for improvement, or even requests for replacement material.
Right, and they're categorized as either urgent or routine.
Let's start with the highest priority, the urgent TFBR. What defines a problem as urgent, requiring an immediate response?
The definition is uncompromising, and it focuses entirely on risk mitigation. An urgent TFBR reports a technical discrepancy or procedural problem that could cause damage to equipment or injury to personnel.
Okay, so a clear safety issue.
A clear safety issue. It also includes any issue that adversely affects the operational effectiveness of a system. If following the book could hurt someone, or if the procedure prevents the system from doing its job in a combat scenario, it is urgent.
That is the cause, risk of injury, damage, or mission compromise. What is the mandatory effect? How must the ship communicate this level of risk?
It must be transmitted via priority naval message. This is essential. The priority message ensures the technical authority receives it immediately. The response timelines are then incredibly rapid and, for exam purposes, critical to memorize.
Give us those critical numbers for the urgent TFBR.
The response is two-tiered and lightning fast. First, the preliminary response. NSWC PhD must provide a response via naval message within 1 working day of receipt.
1 working day.
This response acknowledges the risk. It might ask for clarifying information, or it could issue immediate, temporary amplifying instructions to stop the dangerous procedure.
And the final response.
The final response, which includes the solution, the approved procedure, or definitive guidance, must be forwarded to the ship within 10 working days. This might be transmitted via message to deployed units, pending the formal document revision.
So an urgent TFBR equals a priority message, a 1-day preliminary response, and a 10-day final response. The stakes of injury or mission failure mandate this extreme speed.
They absolutely do.
In contrast, we have the routine categories. They're still vital for system health, but don't pose immediate safety or operational risks. Let's look at routine category A.
Routine Category A TFBRs are purely administrative. They are strictly used to request replacement of lost or damaged CSOSS material, the actual books, manuals, or status boards.
And what is the mandated response timeline for material replacement?
NSWC PhD is required to forward the replacement material to the ship within 21 working days of receipt. This is a logistics function that requires a standard response time.
21 working days.
Okay.
And the routine category B.
Routine Category B reports procedural errors and technical discrepancies that are not urgent. These include minor errors, clarifications needed for better understanding, or recommendations for improvement that do not pose an immediate risk of injury or operational degradation.
So this is the channel for continuous procedural refinement
It is.
and the timeline for a non-urgent procedural fix.
For Category B, NSWC PhD replies via email or message within 21 working days of receipt. If they concur, the response will often include revised CSOSS material or pen and ink instructions that the ship must implement immediately.
It is essential to note that both routine categories, material replacement A, and non-urgent procedural correction B, share the same 21 working day standard response window. The only rapid timeline is reserved for safety and operational effectiveness issues.
The priority is crystal clear.
Let's reinforce those numbers one last time. Urgent for safety or damage risk. Priority message, 1-day prelim, 10-day final.
Right.
Routine for material replacement or non-urgent errors, 21 working days. That sequence demonstrates the policy's absolute prioritization of safety and mission effectiveness.
It's all about managing risk.
Now, we must address the final policy point on accountability. CSOSS is the baseline, but the commanding officer is the ultimate authority for the safety of the crew and the ship. Can a CO temporarily modify CSOSS procedures?
The answer is yes, but only under extremely limited and very specific conditions. This is the exception that really proves the rule of standardization.
And what are the 3 mandatory conditions that justify a deviation?
Okay, 1. When immediate safety or health concerns require a short-term variation from established procedures, the CO sees a high-risk situation and must deviate immediately to protect personnel.
Got it.
2. When systems must be operated outside of normal operating parameters due to verified material deficiencies, meaning the equipment is damaged and the standard procedure would be impossible or unsafe to follow.
And the third?
3. When equipment parameters change due to unauthorized changes, which can occasionally happen in complex systems, for which official CSOSS procedures are not yet available.
So the deviation authority is strictly tied to safety, physical damage, or an unknown configuration state. But the policy closes the loop on accountability here. Deviation is not an administrative shortcut.
Absolutely not. And this is the crucial policy mechanism. Any authorized deviation under any of those 3 conditions must be reported immediately via the TFBR process defined in the instruction.
So the CO can authorize the immediate change for safety, but they must simultaneously report it.
Yes, so that NSWC PhD can analyze the change, ensure its safety, and update the official baseline for the entire fleet. It turns a local emergency decision into a fleet-wide safety mandate.
That is the final piece of the accountability puzzle. The CO has the immediate authority to protect the crew, but that authority triggers the rapid update mechanism, the TFBR, to ensure the technical baseline is quickly and safely corrected fleet-wide.
It's a closed-loop system of control and feedback.
This has been an incredibly detailed exploration, but the structure of CSOS is now, I think, very clear. It is the administrative backbone of technical combat readiness.
It ensures standardization in a high-risk environment. It transforms potential chaos into a clear, manageable command structure.
For the learner preparing for examination or drafting that policy memo, the key takeaway is the structural accountability and integration. You have to master the organizational flow.
You do. The COO or TAO sets the mission.
The CSRO provides the tactical bridge in CAC,
And the CSOW acts as the technical controller in CSMC.
directing the AS and the technicians, who are the only authorized repair personnel.
That's the chain. And you must know the numbers and their implications. The value of CSOS for policy lies in its rigorous, quantified feedback mechanism.
You need to link the risk, the cause, to the response, the effect.
Exactly. Safety risks trigger the 1-day, 10-day urgent TFBR response, while routine improvements receive the 21-day standard. This system enforces continuous accountability and ensures that the technical procedures are always reflective of the current reality of the equipment.
It's fascinating how establishing such strict technical procedure and administrative accountability ends up expanding operational freedom.
What do you mean?
Well, if CSOSS successfully ensures the safe, efficient, and reliable technical operation of the combat system, guaranteeing rapid recovery and consistent safe maintenance, What does that guarantee allow the command structure to do?
It allows the command to act with far greater aggression and tactical complexity. The CSOSS system fundamentally frees the command from worrying about how technical systems will recover from damage or failure.
They know the foundational readiness, the ability to assess damage, reconfigure systems, and repair equipment is a managed constant.
Constantly refined and guaranteed by this standardized procedural system. By mastering the technical how, CSOSS allows the tactical commander to focus solely on the when and the where of the fight, transforming a high-stakes technical vulnerability into a controllable, managed variable.